Here's something fascinating. If you ask ChatGPT to count the R's in the word strawberry, it might actually get it wrong. Why? Because it's not seeing the word the way you and I do. Language models don't read words as complete units. Instead, they break text down into something called tokens. Watch what happens to strawberry. It gets split into smaller chunks like straw and berry. Now, when the model counts R's, it's scanning these fragments, not the full word. That's why counting letters can be surprisingly tricky for AI. But here's what you might be wondering. Why does the word strawberry need to be split up in the first place? Well, language models can't just memorize every single word that exists. There are hundreds of thousands of words in English alone, plus names, places, made-up words, slang, and words in other languages. If the model tried to store every possible word as a complete unit, the vocabulary would be way too massive to handle. So you might think, okay, let's just split everything into individual letters. That way we can handle any word, right? The problem is, if you do that with a word like understanding, that's 13 separate tokens. The model has to do way more work to process the same amount of text. On the flip side, if you try to keep every word whole, what happens when you see a rare word like supercalifragilistic or some brand new slang term? The model just breaks because it's never seen that exact combination before. This is where byte pair encoding comes in. BPE is the algorithm that finds the sweet spot between these two extremes. It learns which character combinations show up together most frequently in language and treats those combinations as single units. So instead of 13 individual letters or one giant word, you get meaningful chunks that can be reused across thousands of different words. It's basically the perfect compression algorithm for language. Let me show you exactly how the algorithm works. We'll start simple with 3 words: berry, Mary, and cherry. First, you split everything into individual letters. Then you count which pair of letters appears together most often. In this case, the letters E and R appear next to each other in all 3 words, so we merge them into a single token called ER. Now our words look like this: B-E-R-I, M-E-R-I-C-H, airy. We keep repeating this process. Next, we might notice that eerie appears in all 3 words, so we merge that into one token called airy. You do this thousands of times across millions of words, and eventually you've built a vocabulary of the most useful subword pieces. So let's go back to strawberry. In GPT's actual tokenizer, strawberry gets split into 3 tokens: STR, AW, and berry. Why these specific pieces? Because STR is a common pattern that shows up in words like string, strong, and street. The AW combination appears in law, draw, and saw, and berry is obviously useful for blueberry, raspberry, and cranberry. BPE figured out that these 3 pieces are way more reusable than just memorizing the whole word strawberry by itself. Here's how this plays out across different types of words. Super common words like the or and usually end up as single tokens because they appear so frequently. A word like running might get split into run and ing, which is perfect because now the same tokens can handle runs, runner, and running. And here's the cool part: even if you throw in some ridiculous word like pneumono ultramicroscopic that the model has definitely never seen before, it can still break it down into subword pieces and process it just fine. So this is why ChatGPT sometimes struggles with counting the R's in strawberry. It's not seeing the complete word as one unit, but it's also exactly why these models can understand basically any text you throw at them without needing to memorize every word in existence. Every major language model you've heard of, GPT, Claude, Gemini, they all use BPE or some variation of it. Now you know how AI actually reads.